Want to learn more about mathematics?
No, but thank you. Thank you very much.
Okay, I was asked to go over quiz 8 key. Again, remember what Yuri, I'm just going to call him Yuri, remember what he said about cell phones. This is one of the reasons I do ask you to not have cell phones on. In fact, in our center, it's immediate dismissal. If someone's on a cell phone or has their cell phone out in front, it's a sign of great disrespect for what's going on, and it's also a sign of lack of interest. So, and the students themselves, just if you're interviewing there, I'll warn you right now that they immediately made X's on any student's application if they came to the interview with their cell phone out anywhere near their vicinity. Just giving you a heads up, you know, it's not just for it's also for professors. We shouldn't be having our laptops open or our cell phones out when there's something going on. I only did version 1 here, but I wanted you to see the solutions because as Quema asked, you should see the solutions. I'm not able to grade everything. I really did try to get them graded, but I wasn't able to get them graded by today, largely because I became sick and I don't have anything in my schedule for being sick. So everybody put it on their calculator, and I think looking through the quizzes, I glanced through it, seemed like you were able to graph this on your calculator and see what it looked like. So I don't have an image here for you, but I can certainly post one if you'd like to see what it should look like on the calculator. What you should have seen, and if you got version 1, is there was a vertical asymptote around x equals 1, and you could even see it in the default window that it was around 1. The second step was to actually find it analytically. So in this problem, it's fairly easy actually in this problem compared to what I did on Monday. In this problem, you just take the denominator, which is x minus 1, set it equal to 0, and you get x equals 1 is the potential candidate for the vertical asymptote, which you secretly know is the vertical asymptote because you saw it on the calculator. Then you make the table with before and after points. The one I showed you Monday was more complicated because there were 3 roots in the denominator, and I had to go before and after each one. Here I only have 1, so I choose a little bit before and a little bit after, and I plug in those values into the y, and I put them into the table. I didn't do the second point, which is 1.001. I think I just wanted you to see what I'm doing. The only thing to be aware of is to make sure your parentheses are around the denominator when you enter it into the calculator.
I put 0.9. Is that bad there?
No, the closer you are to the asymptote, the better you will see what's going on. So for example, here, there's no doubt about it. The 5,000, it's going way up before 1. 5,000 is large. Negative 5,000, it's going way down, which I secretly already knew because I saw it on the calculator.
I did the same thing as, but anyways, the thing is it wrong if we end up...
No, but what if it gave you 50? You are not really 100% sure, right? You have a calculator, it's just as hard to put in 0.9999 than it is to put in 0.9. So I just want to make sure I'm right. So that's what it's telling me, that right before 1 it's going way up, and right after 1 it's going way down.
Professor, actually, when you asked for 2 graph, you said...
Yes, I'm getting there.
Okay.
Watch as the drama unfolds. Okay, the second one was to find the horizontal asymptotes numerically. So there's 2 things. Like when you're graphing a line, 2 points is all you need. Here you've got some complicated looking thing. So you're choosing the points that will make it so that you know what's going around at those important points. One important point is obviously the abyss, x equals 1. You need to know what's going on around there. So that's why I'm selecting my points very carefully. If I randomly select points and connect the dots, it's not going to turn out to be the right graph. By the way, that's what they do in Calc 1 and 2. They randomly choose some points and connect the dots. They might miss the whole asymptote, or they might miss what it looks like at the edges. So the other 2 points that are really important is the edges. So you want to choose an x value that's way to the left. Just make it large and to the left, negative. And then choose a really large positive. Negative 10,000 and positive 10,000 will do.
It didn't have to be like that big. I remember during the lecture you chose 1,000.
That's fine, right? That's fine. I think you get very similar answers. So this is what I got. Those are close to 0. So it's telling me that it's flattening down to 0. The first 0.0005 tells me it flattens down to 0 from above the x-axis because that number is positive. So the second number is negative but close to 0. So that's telling me that it's approaching 0 from below the x-axis. But both of them are flattening out. If it was a large number, it's not flattening out. If it's a large number, it's continuing to grow. So you can, those are hyperbolas. Remember the hyperbolas that look like this? So it could do that, like it could have an asymptote and then go up like this. But these are flattening out. And that was the purpose of the initial, original, outdated, old school reason for asking this question, is to create that graph which you could see on your calculator. And you can see that. With that information alone, I can now create the graph. Number 2. I looked at some of yours already and saw that the equations were wrong. And again, I'm a terrible teacher in some ways because I never force something upon you. I just suggest it and then leave it up to you because I feel like that's better. I don't like to be something forced on me either. So I need you to see the value of it. So again, if you see that you didn't get the equations right, maybe next time you want to try. It doesn't hurt, right? The whole point is to get it right. You have a question, Mike?
Yeah.
Or I saw a hand go up somewhere there.
For the first one, you said to have like a zoomed in part.
Right, so you want to zoom in right around the asymptote to see where that's actually happening. When I did it on decimals, which is a nice, my computer has a nice screen and I can actually see it really well. But sometimes because it's flipping out at that point, it's hard to see what's going on. So you might want to zoom in right at 1.
What would the window be?
I would say around 1, take your x window to be 0 to 2. You can see it flipping out. Yeah. It looks much different on my screen than it looks on. Even the simulator of your calculator looks much better on my screen than it does yours. This is why Dr. Trubatch is against the calculator, because he says for $150, it better be a peach. So it's a ripoff, but you should be getting some really nice graphics, unfortunately. He also pointed out that on your phones, you can get for free better graphing calculators than what you can.
We can use the phones on exams.
I know. Yeah.
I have a question. For the default graph, you actually told us to, because I actually use my standard form window, like the -10,
Yeah.
is that okay?
Yeah. Yeah, whatever you see. I don't care if it's the 10 to 10, whatever you first see, draw that. Because I want to know what you first see. And I want to know how you fixed it. Right? So it's a skill I'm looking for. I'm not looking for a particular answer. I'm looking for the skill of, I've got something and I know that it's might not be the perfect thing. I know how to fix it though.
Okay. So for the second graph, the new graph, like, do I change my movie to like the styles and stuff? Or
You should have seen where the asymptote is, and you want to now zoom in on that asymptote.
for them to get closer?
So you can see right where it's happening. The bigger you have your scale, like if it's -10 to 10, it might be telling you the asymptote is at somewhere around 1, but you can make sure it's really around 1 if you scale in, right? Look closer.
So do we like decrease? Like,
It's just like looking for a root. You're looking right around the important point.
So like, do we decrease the window? Like, do we like change the 10 to like a 2?
Right, I'd say it's 0 to 2, for example.
Professor?
Yeah.
So it doesn't really matter what, there's no like exact number? You have to
No,
see what those two-
no. So I'm again looking forward in time and thinking, what I usually teach courses a little higher up. So I'm thinking about what would I have done if I taught pre-calc to make sure someone's successful here, and that's one of the things, to use that calculator effectively, because like Yuri said, every time you take another class, it speeds up. So if you can get that graph on your calculator quickly and see what it looks like, well, guess what Calc 1's about? It's a lot about graphing. So if you could see this, and know when something's bogus on your calculator, and know how to reshape it. I've given you a skill that'll help you be successful. So that's how I'm thinking about it. So all I want to see is, can you see this thing is bogus? I can't see exactly what I need to, and here's how I rescaled it so I can see exactly what I needed to. Calc 1, you'll be asked about critical points and things like that. It's the same process. Critical points, look at the big graph and then scale it to right where you need to. And I'm still around, so when you get to graphing problems in Calc 1, shoot me an email.
Will you be around this summer?
I don't go anywhere. I have 3 kids. I have no life. Okay, so if you folded this thing up, what you should see is that you're going to lose 4 x's from the width when you fold up the box, and you're going to lose 2 x's length and width, right? You're going to lose 4 x's on the length and 2 on the width. So the volume is length times width times height. Question?
What confuses me is when the x's, when they're colored in and when they're not.
That's why I asked you to fold it, so that you could see, you know, where the dotted lines are, that's where you're supposed to fold.
Is it just where you fold or where you rip off?
Where you fold.
Okay.
I think for volume, because there was one point where it was 5 points, right? I'm not sure if I remember. But I jumped immediately to x minus 208 equals 0.
That's fine, right? It's just as if you made a mistake and you just wrote one answer, my rubric is 0, 0, 0, 0, 0, right? So I have no faith in my abilities for not making a mistake, because I know that I'm going to make a mistake. And I like how Yuri was explaining how he had tips of doing things. Test taking is also a tip, right? I would make sure I had kind of set up little ways to make sure that I didn't make a mistake at the end. So that's a volume thing. I didn't graph it. You graph it, you find 3 roots, it crosses, crosses, crosses.
I put 0.9 for the.
That's fine. Approximately around, mine was exactly through 1. You can zoom in though, you know that. You can actually zoom in and check that it is a root. In fact, I'll put that on the test. Show me that it is the root. So you get these 3 answers, but in the problem you were given that the height has to be smaller than 2.5. So there's only one answer. One.